Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and before we dive into today's topic, I'd like to remind our listeners to rate our podcast on whatever platform you're tuning in from. Your feedback helps us improve and reach more developers like you.
And I'm Victor. We're currently in Season 1, Chapter 5, discussing networking in P2P systems. Today we'll be exploring the STUN protocol, a crucial component in NAT Traversal techniques.
That's right, Victor. But before we get into the details, I have a quiz question for our listeners. What does STUN stand for, and what is its primary purpose in peer-to-peer networking?
Ooh, that's an excellent question, Sheila. It really gets to the heart of what we'll be discussing today. I think our listeners will find the answer quite illuminating, especially when we delve into how it relates to NAT Traversal.
Agreed. Now, let's start by refreshing our memory on some key terms. Victor, could you briefly explain what NAT is and why it's relevant to our discussion?
Certainly. NAT stands for Network Address Translation. It's a method used by routers to translate private IP addresses within a local network to a public IP address for communication over the Internet. This is crucial because it allows multiple devices on a local network to share a single public IP address, which is essential given the limited number of available IPv4 addresses, the most common version of IP addresses currently in use.
Thanks for that explanation. So, how does STUN come into play with NAT?
Great question. STUN, which stands for Session Traversal Utilities for NAT, is a protocol that helps devices behind NAT discover their public IP address and the type of NAT they're behind. It's like a mirror that allows devices to see how they appear to the outside world.
That's interesting. So, if I understand correctly, STUN helps devices figure out their public-facing identity.
Exactly. Think of it like a postal service. When you send a letter, you need to know your own address to receive replies. STUN is like asking the post office, what address should people use to send me mail? It helps your device understand its public address so other peers can connect to it directly.
That's a helpful analogy. How does STUN actually work to achieve this?
STUN works by having a client send a request to a STUN server on the public Internet. The server then responds with the client's public IP address and port as seen by the server. This information allows the client to determine if it's behind a NAT and what type of NAT it is.
I see. Are there different types of STUN messages?
Yes, there are. The main types are binding requests and binding responses. The client sends a binding request to the STUN server, and the server replies with a binding response containing the client's public IP and port.
That sounds straightforward. But I'm curious, what are some real-world applications of STUN?
STUN is widely used in voice over IP, VoIP applications, video conferencing tools, and online gaming. For example, when you make a call using a service like Skype or use Discord for gaming voice chat. STUN helps establish direct peer-to-peer connections between users, even if they're behind NATs.
Fascinating. Are there any limitations to STUN that developers should be aware of?
Absolutely. While STUN is effective for many NAT types, it doesn't work with symmetric NATs, which assign a different external port for every internal host's outgoing connection. In these cases, developers might need to use other techniques like turn or traversal using relays around NAT, which uses a relay server to bridge connections when direct communication isn't possible. Often a combination of methods through the ICE, Interactive Connectivity Establishment framework, is used for the most comprehensive solution.
That's good to know. It seems like STUN is just one piece of the NAT Traversal puzzle. Given these limitations, do you have any tips for developers working with STUN?
Definitely. Always implement STUN as part of a broader NAT Traversal strategy. Use it in conjunction with turn and ICE for the most robust solution. Also, be sure to handle timeouts and retries gracefully, as network conditions can be unpredictable.
Great advice, Victor. Now, before we wrap up, let's reveal the answer to our quiz question. STUN stands for Session Traversal Utilities for NAT, and its primary purpose is to help devices discover their public IP address and determine the type of NAT they're behind, facilitating peer-to-peer connections in networking applications.
Excellent summary, Sheila. To recap the main points of our discussion. Point 1. Stun helps devices behind NAT discover their public IP address. Point 2. It works by communicating with a Stun server on the public internet. Point 3. Stun is widely used in VoIP, video conferencing, and online gaming. 4. It has limitations, particularly with symmetric NATs. 5. Stun should be used as part of a comprehensive NAT traversal strategy, often alongside turn and ice.
Thank you, Victor, for this informative discussion on stun. To our listeners, we hope you found this episode helpful in understanding NAT traversal techniques. Don't forget to visit crashcasts.com, join our Discord community, and support us on Patreon if you enjoyed the show. Your engagement helps us create better content for you. Until next time, happy coding.